The mathematician that I chose to describe is Johannes Kepler. First, here's a picture of Johannes Kepler. Now let's discuss Johannes Kepler's background. First, he was born in Germany in 1571, and he came from a relatively modest family. As such, he had no scientific background within his community, and thus had to attend church institutions, which was pretty common at the time. Kepler came from a modest family in Germany, and thus he attended the University of Tübingen, which is heavily based on religious ideals. It was a seminary, and he obtained a ducal scholarship. In fact, he expected to become either a schoolteacher, minister, or a state functionary, and he wanted to be a theologian. He also claimed that the divine providence had guided him to study the universe and stars, and this made him want to prove that Copernicus, who also developed the heliocentric model of the solar system, was right, and he wanted to explain this through religious and philosophical vocabulary. Kepler was responsible for a number of scientific accomplishments and achievements. First, with Kepler's first and second law, and with regards to his predecessor Tycho Brahe. Tycho was a Danish astronomer who wanted to reform practical astronomy. When Tycho suddenly died, it was Kepler who succeeded him as an imperial mathematician. Kepler used principles and observations of Brahe to discover his first law, which helped him in turn to discover the elliptical orbit of Mars. Kepler then went on to discover his second law, which states that a line segment joining a planet and the sun sweeps in out equal areas during equal intervals of time. Next on to new telescope and Galileo. Kepler also was able to help create a new type of telescope using two convex lenses. This allowed for discoveries that supported the findings of Galileo, who in fact thanked Kepler, as Kepler was one of the only people in Galileo's entire lifetime who supported him. Next, Kepler's third law. Kepler's third law states that the square of a planet's orbital period is proportional to the cube of the length of the semi-major axis of its orbit. The third law expresses that as the farther a planet is from the Sun, the slower its orbital speed, and vice versa. Thank you for listening.